I just recorded a walkthrough of the Simple LLM Finetuner, but I had my microphone on mute, so I'm doing it again. So first things, I changed the name to LLM Finetuner because you can now load different base models to tune. So for this demo, I am running this on a WSL on a 3090 RTX. Is that what it's called? I think so. And yeah, so this is the fine-tuning interface. This is the inference interface. So let's start with fine-tuning. I provided a bunch of example data sets that you can just load up. But first, let's load the base model. Let's go with LLaMa. And this is LLaMa 7B, should load fairly fast. And let's do this data set I called unhelpful, which is GPT-3 generated samples of assistant being unhelpful. And let's call this unhelpful. And let's go ahead and hit train. It's going to take just a few minutes to perform the fine-tuning using the PEFT or PEFT library, using the LoRa, I think stands for low ranking adaptation. I think it just fine-tunes some layers. There's a technique that it uses that I am not very familiar with, but I know that practically it works very efficiently, so you can fine-tune things on data sets. You can probably fine-tune the entire alpaca in about 5 hours, maybe even 2 hours if you adjust these to fit your RAM. So it looks like it's done. Let's go to the inference tab. So first, I already have a prompt set up here. Let's generate it without using any LoRa, and it's giving you some answer. And let's go ahead and put our unhelpful LoRa in here and hit generate. I don't know, ask the cow. So as you can see, it is working and it's being unhelpful. So let's try another model. Let's go ahead and put GPT 2. Cerebrus GPT 2.7b, and let's try the limericks dataset. These are just GPT 3.5 generated limericks. So I'm going to go ahead and overtrain this a little bit by, let's say, give it, I don't know, 30 epochs, and maybe crank this up to 0.8, and let's call it limericks. So overtraining will, make the model spit out the data, which is not exactly what we want, but for demo, these are very small data sets. So for better performance, of course, paste a lot of data here. So this is going to take, once again, not a very long time. As you can see, here we go. I guess it's taking longer than I thought for the demo. What else I can talk about? Inference interface. This is going to load once the training is complete. Yeah, so I am not exactly familiar of how these exact parameters will affect your training. I know that increasing the learning rate might cause overfitting, and then obviously iterating through the data set multiple times using this epoch parameters will also might cause overfitting, but it also helps with these smaller data sets. So the way the LoRa training parameters work, I'd say just ask around or Google. I usually set this one to 32 or 16. I think this just and then I have never changed this one yet. So, but the purpose of this is to just play around and basically, yeah, for you to experiment with how this would work. So currently, a couple of bugs here. It's not giving you the learning rate and the loss at every step or at every logging step. So this is something I'm working on. I am not very good with making Gradio spit out multiple events, especially when it's doing this queuing in this progress bar. Yeah, there could be a few bugs here and there. This currently will work in Colab. I have a Colab, a link provided, and I also have a way to duplicate the space on Hugging Face. You can click this button. Yeah, so let's see, we've done this, so let's go ahead and select limericks here, and let's start without a LoRa and just call it. Let's just start with a limerick. There once was. We're gonna hit generate. As you can see, this is not a limerick. Go ahead and select limericks, and here it is. That is somewhat of a limerick, not really, but if we adjust some things, maybe we can make it sound like one. Top P, I don't know. There we go. That's sounds like a limerick. I mean, this obviously isn't anything close to ChatGPT, but you can play around and create your own models this way. And as you can see, this only took 5 minutes, and we already fine-tuned 2 models. Okay, thank you very much.